This is section 4.5, part B. We'll take a look at using technology to help us to solve rational equations and inequalities. As you see, these can be rather lengthy to solve by hand, and technology is a wonderful way to make the process go more quickly and also to help us ensure accuracy. I'm going to take a look at an equation and then an inequality with the same two rational functions. And we'll start with the equation. Using my technology, I've got my calculator up here, but of course you can also use Desmos or another graphing device. To find out where two expressions are equal, we really are just looking for where they intersect on their graphs. So I'm going to put this one in as my first function, y1, and I'll put that one in my second function, y2. And I've actually got them typed in here for us already, in my y1 and my y2. And since I really don't know what to expect yet, for starters, I'm just going to go ahead and graph them using a negative 10 to 10 or a zoom standard on both axes. There's the left side, the y1. There comes the right side, the y2. Now, one of the things with these rational expressions or rational equations is there's a lot going on. Because of the asymptotes and things, it can be very challenging to remember what's what. We'll talk about that a little bit more in a couple of moments. Right now, though, I think I can see 1, 2, 3 intersection points. And I'd like to go ahead and use the calculator to help me approximate those. So in second calc, I go to intersect. And let's do this one that's really clear on the right-hand side first. Get over close to it. And then just answer the questions. Enter, enter, and enter. And it actually tells me there's the intersection. And remember, I'm only solving for x. So the only thing I really care about is that x value. It's about 3.236. And I'm using the approximations as I round it off. Excuse me. All right. I think there are two more in here, but it's kind of hard to see. There's a lot going on in there, so I'm going to change my window. I can either zoom in, or I can just reset my window. I think I'm going to reset mine to negative 3 to 3 on both axes, just to kind of enlarge that area of the graph. There's the first one, and here comes the second. And now I can very clearly see the two intersections. This one over here on the left. Once again, I just kind of go and get close to it. And then enter, enter, enter. X is about negative 1.236. This one really looks like 0, 0, but just to be sure, let's do it one more time. Whoops, I forgot to move that. Coming over here. And indeed it is. X equals exactly 0. So there are my three solutions to that rational equation. And if I now want to use what I already know to help me solve the inequality, I really just need to know where each function or where the left-hand function is smaller than the right-hand side. Now if I go back to my graph here, it can be rather challenging to keep track of the pieces. If you can, that's great. But I am going to say something like this is much easier to do on either a calculator that graphs in color or Desmos, which gives us a graph in color. It helps me to keep track of what's what. So I actually have a Desmos graph for us to look at here, and I'm going to solve this problem using my Desmos graph. Okay. The red one was the left-hand side. That was our 6x squared over x squared plus 4. And the blue one was the right-hand side. That was our 3x over x minus 1. And we wanted to know where the left, the one in red, is smaller than the one on the right, the blue. So red is smaller than blue in here. Not there for a while. And then let's see, red is smaller. Okay, what happens in here though? That's kind of an interesting question to ask ourselves. For a while, the red one appears to be above the blue, but then over here the red is below the blue again. What happened there? Well, what happened is something changed at the asymptote. Notice back here again, x can't be 1, right? That would put a 0 in that denominator. That denominator is never 0. I don't have to worry about that one. But this one is. So if I were to kind of just draw in at x equals 1 here, this vertical asymptote, that's going to tell me what's going on. Before the vertical asymptote, the red one is above the blue one. But after the vertical asymptote, the red one is smaller than the blue one, below it again. So I want that piece. And then at the end, red is above blue again, so I don't want that as part of my solution. So my final answer here, I want between this intersection point, which we go back here, was the negative 1.236, and 0, I have the red smaller than the blue. So I'm going to include negative 1.236 to 0 as part of my solution. Notice it's less than or equal to, so I use the brackets. Then, from the asymptote here at 1, until that intersection point, which if you look back was 3.236, we again have the red graph below the blue one. So I'm going to go from 1 to 3.236. Now x can't equal 1. That was an asymptote, so I have to use a parenthesis there. But I can go back to the bracket at the end here. And there's my technology solution to that inequality. Again, really recommend that either if you have a calculator that graphs in color, great, but that www.desmos.com is a really nice graphing tool, and it especially helps when you have problems like this. All right, that brings us to the end of 4.5.